Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as network analysis. Let's see this. We'll do crashing today. First let me write the sum down. Activity 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4 and 4 to 5. These are your activities. Normal time. Normal time is 8, 4, 2, 10, 5, 3. Normal cost 100, 150, 50, 100, 100, 80. Crash time 6, 2, 1, 5, 1, 1. Crash cost 200, 350, 90, 400, 200 and 100. Right? Now, they've also given you that indirect cost. Indirect cost is 70 rupees per day. Right? So that's the sum given to you. Now let's see how do we do this sum. Right? Now, first thing that you need to do is you need to draw network diagram. Right? So let's see how do we draw the network diagram. They've given you the activities. On the basis of activities, you will have to draw the network diagram. Fine. Now, event 1. Right? From 1 you have 2. So 1 goes to 2 and it is 8 days. Right? From 1 you also have 3, which is 4 days. Right? From 2 you have 4. So there has to be a 4 somewhere here. From 2 you have 4, which is 2 days. From 2 you have 5. From 2 you have 5, which is 10 days. From 3 you have 4, which is 5 days. From 4 you have 5, which is 3 days. So that is going to be my network diagram. Fine. Once my network diagram is done, let's see the path. Now the various paths are 1, 2, 5, 1, 2, 4, 5. Then you have 1, 3, 4, 5. These are the various paths that I have. Duration 1 to 5 is 8 plus 10, 18 days. 1, 2, 4, 5 is 8 plus 2 plus 3, 13 days. 1, 3, 4, 5, 12 days. Right? So in that case, the maximum duration gives me my critical path. So this is A, you draw the diagram. B, you calculate duration. C, your critical path is 1, 2, 5. Your project completion time or normal project completion time. Your normal project completion time is 18 days. Right? Now, let's find out. Once you've done this, the next thing that you have to find out is direct cost. How do I find out direct cost? Direct cost is the sum of all normal cost. Formula for that is sum of all normal cost. So if I add all the normal costs in the sum that is given to me, that is 100 plus 150 plus 50 plus 100 plus 100 plus 80. I'm adding all the normal costs that are given to me, right? So I'll get my total as 580. That's my total direct cost. Indirect cost. Indirect cost is given to you as 70 rupees per day, and my critical path is 1 to 5, and my project completion time is 18 days. 70 rupees per day. So for 18 days, this is going to be 1260. Once you have this, therefore you can have your total normal cost. Total normal cost is given by the formula direct cost plus indirect cost. Direct cost is 580, indirect cost is 1260. When you add this, you will get 1840. So my total cost is going to be 1840. To complete this project, I'll have to spend 1840, right? Now, what do I understand by crashing? I know that my project can be completed in 18 days. I want it to be completed before 18 days. How do I get my project completed before 18 days? For that, I have to pay you overtime. I'll have to have the labor working overtime for me. If they are going to work overtime, I'll have to pay them extra. So, what is crashing? How many days can I reduce by paying labor how much extra? Right? What is the minimum cost and minimum time in which I can get the project completed? For that, let us see. You have to make a table which is called as your crash table. You have activities. Activities are 1 to 2, 1 to 3, 2, 4, 2, 5, 3, 4, 4, 5. Right? Now, maximum crashable time. How do you find out maximum crashable limit or maximum crashable time? It is nothing but the difference between the normal time and crash time is equal to normal time minus crash time. Right? So, normal time minus crash time will be 8 minus 2, that is, 8 minus 6, that is 2. For 1 to 3, it is going to be 4 minus 2, that is 2. For 2 to 4, it is going to be 2 minus 1, that is 1. For 2 to 5, it is going to be 10 minus 5, that is 5. For 3 to 4, it is going to be 5 minus 1, that is 4. And for 4 to 5, it is going to be 3 minus 1, that is 2. That means I can crash each of these activities. That means I can finish each of these activities early by so many days. So I can get my activity 1 to 2 done in 2 days less. 1 to 3 can be completed in 2 days less. 2 to 4 can be completed in 1 day less. How much do I have to pay for this? I'll have to pay my labor overtime. That is called as my cost slope. Cost slope is given by the formula crash cost minus normal cost upon normal time minus crash time. Right? Now, in the first case, crash cost minus normal cost, that is 200 minus 100. For this, for activity 1 to 2, this is going to be 200 minus 100 upon 8 minus 6. That's 100 upon 2, that will be 50 days, or 50 rupees, sorry. Now, for 1 to 3, crash cost minus normal cost, 350 minus 150 upon 4 minus 2. That's 200 divided by 2, so that is 100 Next, for 2 to 4, it is going to be 90 minus 50 upon 2 minus 1, right? So that's 40 upon 1, that is 40. Then you have 2 to 5, that's going to be 400 minus 100, 400 minus 100 upon 10 minus 5, that's 300 divided by 5, that is going to be nothing but 60. Then you have 3 to 4, that is 200 minus 100 upon 5 minus 1, 100 divided by 4, that is 25. And finally you are going to have 100 minus 80 upon 3 minus 1, right? That's 20 upon 2, that is 10. So you know the activity, you know what is your crash time, and you also know your crash cost. Now you need to rank them. How do I rank them? I have to rank them in ascending order. So out of all the crash costs that I have, the smallest crash cost is 10 rupees. So that will be given first rank. The closest to that is 25, that will be given second rank. The closest to that is 40, that will be given third rank. The closest to that is 50, that will be given fourth rank, fifth and sixth. So you need to rank them. So that's the order in which crashing has to be done. You always crash the least cost first. Fine, do we get this in clear? Now, if I crash this, what will be the difference in my cost? Let's try to find this out, right? Let's make the crashing table now. Crashing before crashing. Now what are the various paths that I had? The various paths that I had were AD. The various paths that I had were 1 to 2, 1 to 5, 1 to 4, 5 and 1, 3, 4, 5. Fine, do we get this? So the paths I have is 1 to 5, 1, 2, 4, 5 and 1, 3, 4, 5. These are my various paths. Once I have the paths, the time for each one of them is also known to me. This is 18 days, 13 days and 12 days, right? Now let's see how does it affect my cost. Cost is made up of direct cost and indirect cost. That gives me my total cost, right? Direct cost we found out was 580 rupees before crashing. Indirect cost was 1260 and this was 1840, right? So that's how, that was my entire data that I have. These are my multiple paths which have to be crashed. Now let's see this. Now let's understand the rules of crashing, right? You start only critical activities have to be crashed. Please write the rules down. Write the rules down for crashing. Only critical activities are crashed. Only critical activities are crashed. Crashing is started with critical activity. Crashing is started with critical activity. Crashing is started with critical activity having minimum cost slope. the critical path should always remain longest. The critical path should always remain longest. Now, my critical path is 1 to 5, right? So in that case, the first I have, what we'll do is, guys, we'll name this, guys, we'll call these activities as, say, A, B, C, D, E, F. Let's call these activities by these names. Right, that will enable us to do crashing more easily. Right, so I have 1, 3, 5. So guys, let's see the critical diagram. 1, 2 I'm labeling as A. Right, 1, 3 I'm labeling as B. 2, 4 I'm labeling as C. And 2, 5 I'm labeling as D. 3, 4 I'm labeling as E, and this is F, right? So in that case, the paths that I have here is 1, 2, 5 is AD, this is 1, 2, 4, 5 is ACF, and 1, 3, 4, 1, 3, 1, 3, 4, 5. 1, 3, 4, 5 is nothing but BEF. Right? Now, crashing has always, the first rule says that crashing always starts with critical activity. My critical activity here is AD. That means I have to do crashing of AD first. Now, AD is made up of two activities, A and D. Find the rank of A, find the rank of D. Now, if I look at my table, guys, the rank for A is 4 and the rank for D is 5, right? You will start with that activity first which has a smaller rank. A has a smaller rank, therefore you will start with crashing of A. Now A can be crashed for how many days, guys? A can be crashed for 2 days. You will not crash both the days simultaneously. Crashing is always done 1 day at a time. So you will have first crashing is A by 1 day. If I crash A by 1 day, guys, A by 1 day, instead of 18 days, now my task will be completed in 17 days. Wherever I have A, I'm going to reduce that time by 1. Here, instead of 13 days, this will become 12 days and this will remain as 12 days only. Right? I'm crashing it by 1 day, I'm reducing 1 day. Now to reduce 1 day, what is my direct cost going to be? My direct cost was 580 rupees. Now look at the cost slope of A. The cost slope of A, guys, the cost slope of A is 50 rupees. That means to crash A by 1 day, it is going to cost me 50 rupees. So my direct cost will be whatever was my direct cost plus 50 into 1. That's my cost slope is 50 rupees into 1 because I'm crashing it by 1 day. So this comes to 630 rupees. Right? Indirect cost is now I'm going to be completing the project in 17 days instead of 80 days, and my indirect cost is 70 rupees per day. So this comes up to 1190. If I add the two, I will get this as 1820. If I add the direct cost and indirect cost, I'll get 1820. Now you will realize something, guys. I was completing the project in 18 days and I was paying 1840 rupees. Now I'm completing the project in less time and it is also beneficial for me. Question: till what time should I keep doing crashing? Till the time my cost goes on decreasing. The point where my cost increases, I stop crashing then. Okay?
So what if the cost is constant?
In that case, there's no. Then you are saving on time.
Okay.
right? You
So
stop crashing the
we have
moment
to continue.
you stop crashing once your cost increases, right? Now let's see this. Now we know that A can be crashed by 2 days. A can be crashed by 2 days, out of which 1 day crashing I've already done. So now I'll have to do second crashing. That's another A by 1 day. If I crash A by 1 day, instead of 17 days, I will reduce the work time by 1 more day. So this will become 16 days. This path also has A, so this will become 11 days. This will become 12 days. My cost was already 630 rupees. I'm crashing A by 1 more day, right? The crash cost of A is 50 rupees per day. So when I add this, this comes to 680 rupees. Fine. Instead of 17 days, now my project is getting over in 16 days. So my indirect cost is 70 rupees per day. For 16 days, I will pay 1120. My total cost is direct cost plus indirect cost. So that comes up to 1800 rupees. I'm finishing my work in 16 days and I'm paying only 1800 rupees. Okay. I finished crashing of A by 2 days. The next thing I need to crash is D. D can be crashed by 5 days. And its crashing cost is 60 rupees per day, right? So you will have third crashing D by 1 day. You have to crash 1 day at a time, right? If I'm going to crash D, instead of 16, this will become 15 days, right? This will remain as 11 only because there's no D involved in this. This will remain as 12 only because there's no D involved in it. Right? Do we get this thing clear? Now, my cost was already 680 rupees. I already told you that the crashing cost of D is 60 rupees per day. Right? So this is going to be nothing but 680 into 60 by 1, which will come to 740. I'm completing the work in 15 days. Indirect cost is 70 rupees per day. So that will be 1050. Right? If I add the two, that comes to 1790. Right? Project completed in 15 days and project cost 1790. Next, I know I can crash D by 5 days. I've only crashed it by 1 day. So let's move on to the next crashing. Crashing D by 1 day. Right? So instead of 15, this will become 14 days. There is no D in the second one. There is no D in this part, so this will also remain the same. My cost was already 740 rupees. Crashing cost is 60 rupees per day. So this will become 800 rupees. Right? I'm completing the project in 14 days and my indirect cost is 70 rupees per day. So this comes up to 980. If I add the two, I will get this as 1780. Right? I finished crashing D by 2 days. I can crash it by another 3 days. Fifth crashing D by 1 day. Right? Instead of 14, this will become 13. Right? If I'm going to crash D by 1 day, 13, 11, 12. Fine. So in that case, I already was spending 800 rupees. My crashing cost of D is 60 rupees per day. This becomes 860. Right? Now I'm finishing the project in 13 days. 13 into 17. So that is going to be nothing but 910. When you add this 860 and 910, you will get 1770. Right? Sixth crashing. I'm going to crash. I've finished crashing D by 3 days. I can crash it by 5 days of maximum. So I'm doing the fourth crashing of D now. 13. This becomes 12 days. Right? This becomes 11, this becomes 12. Fine, do we get this thing here? Now, here this is 860 plus this is going to be nothing but 60 into 1 because my crashing cost is 60 rupees per day. So this becomes nothing but 920. I'm completing the project in 12 days. 70 rupees per day comes up to 840. When you add this comes to 1760. Right? Now, the final crashing. I finished crashing D by 4 days. 7th crashing. D by 1 more day. Now, if I'm going to crash D by 1 day, it is going to become 11. Right? This, now, in this case, my critical path becomes less than the other path. The time of the critical path should be maximum. If I crash till here, the critical path, the time of the critical path and the other path, that is your B, E, F, was same. But now if I crash my critical path by 1 more day, then in that case, the time of my critical path becomes less than that of the other 2 paths. It becomes less than this. So in that case, although I do not have a D in the other 2 paths, I will still crash them. So this will now become 10 days and this will now become 11 days. I have to make sure that my critical path is the path having maximum duration. Right? Now, let's see this. Now, where was it necessary to crash this? Suppose, had I not crashed this would have still been 11 days, it would have been equal to my critical path. This, I was forced into crashing this, otherwise then my critical path would have changed. Right? So now observe carefully. So this will be, I already have spent 920. The cost of crashing D is 60 rupees per day. And in order to keep AD as my critical path, I have to crash BEF. Right? So if I have to crash BEF, I have to crash now in B, E and F. Out of the 3 paths, the smallest rank is of F. Out of B, E and F, the smallest rank is of F. So you will have to crash that first. The cost of crashing F is 10 rupees. So into 10 into 1. So in that case, this will come to 990 rupees. Right? Do you understand this? Now, here this is 11 days, 70 rupees per day, 770 rupees. When you add this comes to 1760. My cost remains the same. I finished all the possible crashings. Fine, do we get this thing clear? So now, my final answer will be my optimum project cost. Optimum project cost. What do you mean by optimum project cost? Optimum project cost means my minimum total cost. Minimum total cost. The minimum cost is 1760. Fine. My optimum project completion time. Project completion time. Optimal project completion time will now become 11 days instead of my 18 days. Fine. That's your time corresponding to optimum project cost. That will be 11 days. And minimum project completion time. Minimum project completion time. Minimum project completion time. Minimum project completion time is the time at which crashing process ends. Is 11 days. Guys, please understand this. There is a difference between optimal project completion time and minimum project completion time. Optimum project completion time is that time which corresponds to optimum project cost. This is the time which corresponds to optimum project cost. project cost, right? So optimum project completion time is the time that corresponds with optimum project cost, and minimum project completion time is the time at which crashing process ends. Time at which crashing process ends. Fine, do you get this in clear? So do you understand how we do a sum of crashing? Right. Okay, this finishes the sum. We'll stop this here for the day. Thank you very much.